This is video 6.2.1 and the goal is to solve systems using substitution. Many of you are struggling with this, so I really need you to pay attention and I need you to ask questions and definitely listen for when I talk about and when I come around to help you and help you find your mistakes. If you understand what substitution is, it will help you. So the first thing that we're going to answer is, what is substitution? Just like you know substitution in English and in real life, we use substitutes for teaching to replace the teacher, right? The substitute is in the room when the teacher is not in the room. Somebody gets replaced. The same is true for substituting in a basketball game. You substitute one person out, the other person goes back in. There is always going to be a replacement with substitution. Now, with math substitution, the requirement is that the things are the same. So you can only substitute things that are equal, and that is what's key here. So substitution in math is replacing something with an equivalent, so equal, with an equal, we use the word equivalent in English, with an equivalent expression. So the same thing, that's what I'm trying to say here, that we're going to replace it with the same exact thing, it just looks different. So what's key here is that we figure out what we're going to substitute. So in this first example, the y is the variable that's alone. That's the variable I'm going to substitute for, and I'm going to substitute for it in the other equation. So I like to circle my y's in this case because that's what I'm going to replace, because I see y equals 2x minus 3. These three purple circles are all equivalent. They are all equivalent expressions. They're all the same thing. Now I'm going to replace. So I start with copying what I'm not replacing. I copy the 2x. I copy the 3. But where the y was, I'm going to replace that with 2x minus 3, because that is equivalent to y. Notice everything else stayed the same. And then, of course, I copy the 7. The reason I do this is because I'm trying to find where these x's and y's are equal for the two rules. And so I'm taking the y from one rule and I'm putting it into the y in the other rule. I'm substituting it in. Now the process is solving. Some of you are making mistakes with the substituting step. That's this first step here. And some of you are making mistakes with the next step. So continue to pay attention to make sure that you know what to do next. The next thing we need to do is solve this equation. And we learned in the last chapter that we solve this equation by taking care of these parentheses. And the way we do that is we distribute the 3. And since it's a plus 3, we're distributing a positive 3. So again, I copy other things down. I'm going to copy the 2x and I'm going to copy the 7. But I am going to distribute the 3 to the 2 and do 3 times 2x, 6x. And of course, that's plus 6x. This is positive. 3 times negative 3 because of the minus here, so it's going to be negative 9. 3 times negative 3 is negative 9. Now I have a much easier equation, and I'm going to continue solving. The next step is always to simplify. So we start with simplifying 8x minus 9 equals 7. We have a simpler statement now. And then we just continue solving. And to solve this, I need to get the x's alone. I'm going to add 9 to both sides. Now my x's are alone because that made this 0, and I have 8x alone equals 16. My last and final step is to divide both sides by 8. So again, I can get 1x alone, and 16 divided by 8 is 2. And I have one of my two answers for this system. So I've solved for x. But remember, we always have to go back and find the other variable, because the goal is to find the solution to the system, which is an ordered pair point. So now I'm going to go back to one of my rules, usually the one that makes this easier, and this one's going to be easier because I'm going to do y equals 2x minus 3, and I'm going to put 2 where the x is, minus 3. Now I have an expression that describes y. Y is 4 minus 3, or 1. So my answer is 2, 1. This is my solution to the system. X is 2, y is 1. Now what's beautiful about this, and some of you need to listen to this step because you're making silly adding errors, is I can take this number, 2, 1, and I can put it into the other rule. And I can check my work. Okay, I'm going to do that over here, and then I'll erase my work so I can work later. 2 times 2 plus 3 times 1 should give me 7. I'm trying to make sure it gives me 7. If it does, then I've got the right answer. Let's see, 4 plus 3, that is 7. So my answer checks, and it's the correct solution to the system. Let's take a look at the next one. This next type was causing a lot of problems as well because of the parentheses. So this next one, again, we're substituting. In this case, though, we're substituting for x because x is the variable that's alone, and x gets replaced in the other equation. Now 5 minus y is the same as x, so I'm going to put 5 minus y in for x. These 3 green circles are equivalent. Now I'm going to substitute in. Again, I copy the 4y, I copy the negative 16, but where it says plus x, I do plus parentheses 5 minus y. I replace the x. Now I need to solve. Here's where a lot of you are making mistakes. This is plus parentheses. There is no distribution like we saw over here. There is no distribution because there's no number right here. There's nothing to distribute. This simply says 4y plus the group 5 minus y. So I'm just adding these two groups together. And when I add two groups, I really don't change anything. So I can simply rewrite this without parentheses. I did not need parentheses here because there was no number in front of this x in my equation. So I did not need parentheses. I have them in there, and that's okay. I should know how to work with that. That is something you were taught way back in chapter 2 even. Now let's look at how to solve this. Now with the parentheses gone, everything gets easier. I don't have to multiply anything. So let's see, putting the y's together, because they're on the same side, I get 3y's, because 4y minus y is 3y. I still have the 5 equals negative 16. Now I need to get the y's alone, so I'm going to minus 5 from both sides. So I have the y's alone, and I get this gone, because that makes a 0. 3y equals negative 21. Be careful with your adding things like this. Use your calculator to verify. Our next step is to divide, of course, to get 1y. And we end up getting y equals negative 7. So I got my y value, negative 7. Now I always have to go back and get my x value. So I always have to have both variables. So I'm going to go back, and I think I'm going to use this equation because it's easier, because it simply says x equals 5 minus y. Since y is negative 7, I'm going to enter that in for y. Again, it's like substituting. Y 5 minus y. And of course, when I substitute in, I should probably use parentheses. Do not lose these negatives. They are important. This was the subtraction. That's what that one was, and the other one was for the negative on the 7 in our answer. Now we do the math. 5 minus negative 7. Hopefully we know that we can change that to 5 plus 7. If not, we use a calculator. The answer for x is 12. And last but not least, I should know how to check my work. So I go back to the other equation that I haven't used, and I plug in for y and for x, and I make sure that I get negative 16. So I put 12 in for x and negative 7 in for y. 4 times negative 7 plus 12, does that equal negative 16? And if I get negative 28 plus 12, equals negative 16. That looks like it's going to work. Negative 16 equals negative 16. I am good. The correct solution is 12 for x, negative 7 for y. So I put them in an ordered pair, and there's my answer to the system. So huge mistakes happen with the parentheses in a problem like example 2. And in example 1, it's more often where we're substituting. So carefully think who is getting replaced. Circle things like I try to circle things. That's why I do that. It helps you follow my work. It'll also help you make less mistakes. So hopefully this helped clarify some things. Now I want you to go ahead and be careful and solve the next 6 problems. You will be doing a concept check on this to try and pass out of this concept. I want everyone to show me they get it so we can move on. Okay? If you need more help, keep asking questions, keep working hard, and I'll be around to give you the help that you need.